Hi, this is going to be sort of my walkthrough of a project I've been working on for a long time. I've kind of called it C16 OS, Commander X16 OS. Kind of in general, multitasking OS for the Commander X16 computer. Kind of designed to look like Unix and terminal based. Not POSIX compliant at all or anything like that. It's just kind of the design, is trying to recreate the flavor of Unix or Linux or anything like that. Again, terminal based. There is a little bit of GUI program that puts your terminal into a window, but I wouldn't really call that a GUI. And through this project, because there's so much limits, I'm going to try to take advantage of the X16's features to make something like this possible. So some of the main features, a shell, which I think is really cool, pretty cool shell. Preemptively multitasking, not cooperative, so it's more advanced than a Macintosh, or at least the early Macintoshes. And not really, but at least in this aspect it is. Not and redirection, and which is cool too. As a note, it does only run on X16s with 65816s. It originally did run on 65CO2. There's you can look at old versions that do if you want to check it out. But the 16-bit features are just unbelievably helpful when just making the kernel faster. Strings, it's so much easier to work with when you don't have to worry about like the Y, your indirect Y overlap or wrapping around. A lot of my functions only supported strings up to 256 bytes because of that. And it makes programs run faster. It makes kernel run a lot faster because you're dealing more with strings. Just very helpful. And I have an 816 in my X16, and I'm probably the only one who's ever going to use it anyway, unless any of you get really attracted by it and find it interesting. So it works for me. Yeah, so let's get into it. I'm just going to, run it in our terminal or run the emulator in my terminal window and open it up. So let's go into full screen here, and we're just going to cd into the OS directory and boot. Oh yeah, this is actually left over from my previous recording. I wasn't super happy with it, but what I did do at the end of that recording is actually create a .srh file, which sorry, kind of ls-a because dot files are hidden. But if we add, which is another program I have, and we print, yeah, it says hello world. So that's where that hello world came from. And there is support for actually both the bootrc, which only runs once, like on boot up of the system, and then shrc, which runs every time the shell starts up, which is helpful. Like if you want to launch the swap term, which I'll talk about in a little bit, you can't do it every time a shell opens up, or you're basically going to crash your system. But yeah, it's stuff like that. So you can have like a startup shell script, kind of like a bash rc. Obviously, it's what it's modeled after. I'm sure the original Bourne shell or the original sh does the same thing. No, sorry. And Ed is one of the several programs I have on here, along with ls. So let's look at that. So all the program binaries are contained in the bin directory, and it's basically a path. So if you type in a program, it's going to look without a dot slash. It's going to look in this directory. So any of this, so like ps, cat, it's not going to do anything. Echoes again, or it'll print a new line. rm will say missing operand, stuff like that. Color, we'll change the color of the background. Can't really change the foreground color because the shell overwrites it. Let's change it back to black. But yeah, all these binaries here do what they generally do in Unix. So let's look at sort of, I'll say my favorites. First, you got ed. Pretty cool, honestly. It's pretty well featured. I got most of the commands from ed in here. I think there's no regex, which maybe I'll do eventually, but I figured it wasn't too important at the beginning because I just wanted something able to edit files without having to cat and echo and redirect into a file or something like that, which isn't the best, obviously. But you can edit files as I showed you, or you can actually edit programs. So the same format you do on a normal installation of ed, you use the exclamation port or exclamation mark, and it loads the output of the program. So if I print now, you actually even get the color. But yeah, so you get the output of ls-a, which is pretty cool. So yeah, you can edit files. I mean, it's just like if I want to delete 1,2, and I can delete that, and I can print it again, and I can I can like delete every directory. This will be 11 now, I think. It's gonna be 11, I think. Yeah, so there you go. All the directories are kind of deleted out of there. So now you only have the files. If you wanted to save that for whatever reason, you could by just writing. I won't because I don't really want to, but Q, it will actually prompt you if you've like done any work, but it will quit that way. So let's clear the screen so you can look at it. Let's see what I want to show next. Alright, let's look at NeoFetch. It's just kind of like the kind of thing on Unix or Linux earlier, or really any systems on Mac, Windows, stuff like that. Even there's actually a version for the X16 already, which I stole one of the arts from. But this actually updates live to kind of the actual stuff on your system. So I do have this is the R48 version emulator. 29 is actually the number of programs I have in the bin directory. So if you count up here, I did for the last recording, but it is 29. And if you add more, it will change the number. Shell, the name of the shell I'm running is shell, so that's not a lie. Terminal is right now it's just the X16 kernel. It's just calling CHR out. So that's CPU. As I said, it only works on the 65C18 Vera. That's the Vera version on here. And normally when you start up the emulator, you only get 512K, so that's what it shows, which is 64 banks, and all these colors too. What I'm going to do is I'm going to move the etc file, or I'm going to cd into the etc directory, which is where you really only this config file is stored, but right now NeoFetch is. So we're going to move NeoFetch, config to, let's call copy. It doesn't really matter. And if you look at NeoFetch now, it's the traditional. This is the kind of default look. This art is actually the one stolen from the other NeoFetch. So thank you for that art. ADIEE. They're the person who put it together, and I really like this art. But it was better than the one I did, which is the one we already showed. If you copy this back. Much better than mine is, which is just backslashes and types and forward slashes and stuff. Doesn't look very good. All dashes too. What you can tell, it changes, and actually, it's a little harder to tell. But in this one, there's a couple blank lines printed before the OS line. Like so, if you look at if you cat at neofetch.com, you can see that blank is printed twice, so you get two blank lines, which you can basically customize it however you want. Sort of like a real new config file, although the format's obviously not the same. And kind of the last thing I'll show you I'll show you two things. So let's show the GUI, which is kind of I gave Wreath word to, but it's basically just a way to put your output into a blank window. This is actually in bitmap mode, which is pretty cool. It's actually pretty fast. So we're still in the etc. It's actually black and white because this is in the 8-bit per pixel bitmap, which actually means that can be 640 by 480, although it is black and white, which I think is okay because I think that's better than the alternative. And you actually get this, and it does actually scroll. So if I access the, let's do something smaller. Sorry, bin.cat. So yeah, you can see this, it prints, it scrolls. The scrolling is obviously a little slower because you gotta move all this data, but it does work. And I can even kill, or actually see what process GUI would be. I need to kill 22, and then kill 18, kill 18, and there we go. So that's pretty cool. I'll show you swap term now. So swap term is actually another kind of terminal mode you can have. So this actually lets you alternate between two terminals running at the same time. So you can see I'm pressing tab and escape right here, and this switches between. So now I'm in this directory, and this is a different shell, which will clear. Now I cleared that one, but it doesn't clear this one. And now I can even show you my assembler. So this assembler, it works in it only works really for 6502, but I think that's fine. The OS routines really help you in programming 6502. It makes it a lot easier. to work with a lot of stuff like files, especially. It's a lifesaver with files. So I can assemble test.asm, which is actually this touch program, but also it normally assembles to a.out. So we'll go there, and we'll even switch over to my other terminal to run this program. So we get ls here, a.out is here. We're in a.out. Our some file name, and this should create FFFF. That is a 9fs, which I'm going to probably mistype. There we go. RM FFFF. I've already messed it up, but now you can see it's obviously gone. So yeah, that's kind of the main things of the OS I really wanted to show off. I have a lot of stuff here, so actually I think we already showed it, or I ran ed twice, and we kind of saw that. We saw the output of other programs. It will be stored in this temp directory. So this might be ls. Or sorry, it's obviously not directory, so that doesn't work. Okay. But, you do get some error codes, which is nice. But yeah, so this is actually output of an ls from earlier, and let's see what the other one is before I mistype it again. Do not have auto-completion in the shell yet, so probably won't ever, but see, this is a different time. I think it's actually just, this one's ls-a, so you can see the dot files being printed here. So that's pretty cool. I think just overall it's it's been a lot of work, and it's pretty cool. It's kind of stuff where it's gotten to the point, especially with the assembler, where I can program new utilities on the assembler or on the machine itself, which I have right beside me. So example, like NeoFetch right here, it prints the terminal, but how I learned, not that it was complicated or in the OS, but how the first did this was actually I wrote a TTY program which just prints, or TTY on Unix prints the name of your shell, or your terminal rather, and I wanted to do the same thing here, so I wrote that on the machine, compiled it on the machine, and runs it on the machine. It works perfectly. So it this prints swap term, but if I kill, we're in swap term now, you can see it prints the name of the shell. But if I can't kill 18 and then kill 24, or kill 22, and clear, now if I fetch again, it's going to say X16 kernel is my terminal, because I'm just printing the chart now. So hopefully, I think that's pretty cool. I'm showing my new fetch now like 5 times, which is probably a little annoying. But I hope this was a cool demonstration of the OS, and that maybe you're inspired to write your own programs for this. I think it would be great to have like a real developer community, and it could really give you some direction on what features would be cool for programmers, because I'm starting school now, so I'm getting to the point where I got to step away from it a little bit, but I still want to see it develop a little bit, which would be be great if anyone got interested in this. And I think it is pretty cool, and hopefully some of you are interested in it. I'm going to report a second video that kind of goes more of the specs and just how it works. They'll be coming later. Won't be separate from this video, just if anyone's interested in programming or just interested in how it works, stuff like that. They'll look out for that. So thanks for watching. Let me write some dumb message. One last thing, you can see when you quote something, it goes into one argument on the shell. But yeah, really, thank you for watching this. I know I can be a little bit of slog maybe, but hopefully it's pretty cool.